Good afternoon. I'm here instead of Peter Molnar, who is head of my institute in the university. So I am Apol Temesi. I'm a teacher at Moholi Nagy University of Art and Design. And I have been leading a course for 3 years, and it's called Compo, like biocomposite materials. And this new approach based on my doctoral research, and it's about sustainable material usage. For example, waste-free technologies, low energy usage, and using local materials. And it's also about how can we take more responsibility as designers. And of course, we would like to participate the climate discussion. So we have our own methodology, and it was inspired by the material-driven design from Elvin Carona and Valentina Rognoli. And we continue the work and changed a lot of details and created our own approach. So we work with a protocol and agile methodology, so step by step, and with a lot of reflections. And we have two topics: the industrial waste, especially waste from the building industry, and the second one is the renewable local materials. And I'm very proud that some of my students continued the work with this approach in their master degrees. And we are also happy because we already have partners, other universities, for example, from Hungary and Italy. In the first period, we examined it with several topics. So here you can see our main topics from the first years. But then we narrowed down our research areas for two main topics. The first one is a waste from the building industry, of course. We see waste as a raw material, and we are investigating its potential. So we change their state of matter and explore their potential. So we use basic recipes and see how can we change the properties of the material. And here you can see the 5 most successful student works with the choose materials. And last semester we started the second research project. So we are looking for a local renewable materials, and I involved 2 new colleagues in the research. The first one is a botanist, and the second one is a plant dyer textile designer. And we started to investigate our environment. So we are looking for renewable raw materials. And we decided that we will work with our invasive plant. It's called green maple. We have a lot of problems with this material, so that's why we chose this one. And so it's a very complicated topic. That's why we work together with colleagues from other scientific research, scientific fields. And from the first step, we worked with one invasive plant. We examined this plant as a dyeing plant, and see how colors change, for example, with acidic or alkaline effect. And it's really important that we use just natural components and effects, so without chemicals. And in the second part, with the same material, after soaking, we use every part of the plant separately or together too. And with really basic recipes, we develop new materials. And yeah, so after this semester, we would like to narrow down the topics and continue deeper the research and continue with other invasive plants from Hungary or from this area, and continue this approach. So thank you so much.
Wow, that's amazing. That's amazing. Can you tell me just a little bit more about the materials itself, or can you zoom it? Because they look so beautiful, and I
Yeah,
guess,
so
yeah.
these are the whole project. It's from green maple.
Mm-hmm.
And we examined some very interesting topics. So, for example, we are working with mineral water, and we just see how, for example, here, how the color change. And especially this one is about soil pollution. So we examine if we have the same material from our small island and from the city center, the color changed because the soil pollution it changed the color. And it's also about natural post-treatment, for example. So at first we soak the material, so we create an extract, and then we put the material to the extract, and then we continue the work with post-treatment, and we take there some really easy, like citric acid or soup or anything else, so really natural materials, and we just see how the color change. So for example, here you can see this project is about oat milk. So for post-treatment we use just milk, and you can see how color change. So we really like it. We would like to continue our work with this way. And in the next semester, we can continue with another invasive plant. It's also from Hungary, so it was just one tree. And earlier, it could be also interesting. I zoom in. So those kind of materials. Whoops, sorry. The whole material on the table, it's from tile, and we mixed it with concrete waste, and the pigments came from bricks, for example, and it's also basic recipes. So we use just basic recipe, and we just see how the material flexibility change, the color change, and how can we mix other type of materials, and is it usable after we worked with the material or not. And as you can see, every sample is very useful, and we can continue the work with the recipe.
That's amazing. That's amazing. And one more thing, because Piconut, it started with the aiming to map, all these practices, and to record this traditional knowledge and of course communicate it. But as soon as we're going through the project, we are seeing that a lot has been done, and well, we can talk about Portugal. A lot here is already being mapped or is already mapped, and in different platforms. Okay, for example, today here we have SEART, that is a really important play role in this situation, but we have also others. And one thing that we are aiming, so we're kind of changing because it's like thinking how can universities and how can formal education really get this knowledge, and
Yeah.
and deal with it. So
Yes.
yeah, so can you tell me
I
a little bit
Yep.
more about it? Yeah.
Yeah, earlier I mentioned we use protocol, and for example, here you can see after we use a receipt, we filled out a protocol. So it's an open source research, and it is because we would like to continue from this stage. So we don't with every student we can't start the work from the beginning. So that's why we fill out this protocol, and for the next semester we can continue from this stage. Yeah. And I think it's able to be open for another universities, because from the protocol you can see the whole method, and you can continue, or you can make it again.
That's perfect. If you have, or if you could send us the articles and the protocol so I can share with everyone.
Of
It's really
course,
amazing. Okay.
Yeah.
Does
Yeah,
anyone?
it would be really nice if you do the same method with another invasive plant, or another plant, or another waste from the building industry. So it would be really nice.
Yeah, that's perfect. That's
Yeah.
perfect. Does anyone else has a question for Apple? Apple, I don't know how to pronounce your name, so I'm sorry.
It's Apol.
Apple. Okay, thank you. And sorry.
Of course.
Yes, sorry. Do you have any example of the exit, like I don't know, some products suggested by your students with you here? Otherwise, I will be very happy also to receive, let's say, the link to your publication, because it's very, very interesting. Thank you.
Thank you. I don't have any pictures about the master degrees, but maybe you can find it from the university's homepage. Yeah, it's a little bit complicated, because I can show just the pictures about my courses, and not about. But maybe Molnar will send you pictures about the master degrees, and you can see how the work continued after this course.
Okay, thank you so much. If you can link me here the website, I will immediately go, because I'm very curious. Thank you.
Okay. Thank you so
Thank you
much.
so much.
put it in the chat. And Carla, you have a question as well?
Well, I was curious about rather a practical question. When you described the method of reusing the bricks from, I guess, from, I don't know, from construction companies, or do you have a laboratory, you have some mixers, or how you bring all the bricks into dust and then you remix them with different kind of glues, or how you do it?
It's really funny because in my university we don't have any laboratory. So everything what you see in my presentation, students made it in their kitchens.
I see.
So with really easy tools. But especially in this project, so when students worked with waste from the building industry, we have a very good collaboration with Veszprém University. It's also in Hungary. It's another university in another city, and they are working with ceramics, and they helped us. So they did the powder from the tiles and the bricks. So it was a very big help for us. And but after when students had the powder, everything happened in their kitchen.
Yeah, I understand. I was curious because it's not an easy job, you know, to take the brick or the tiles and transform them in any manner you would like to do. You need to get back to dust. And I was just curious. And you also mentioned that you work with a botanist, or I understood correctly.
Yes.
And
yes.
do you how exactly the botanist it's involved in the teaching?
This guy Attila Rigó, so here you can see his name. He helped us to pick up the perfect plant. So he gave a short presentation about the whole problems. So the problems about invasive plants is not so easy. So we should understand what is the real problem with the invasive plants. So that's why I involved him, because I'm not biologist or botanist. And the second question was how can we start the work? So he gave the presentation about the whole problem around the world, and then we started to focus on Hungary, the Hungarian invasive plants, and then we pick up just one, which is in Budapest, so in our city. So he just helped us at the beginning of the process.
I understand.
And after the semester he checked the students' work, but he never saw any design project about this topic. So yeah, it was a big surprise for him.
No, thank you.
Well, thank you